started. So for the first question, it says a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h is given by the function where a of h is measured in square feet. The function a is continuous and discrete, decreases as h increases. Selected values for h, a of h, are given in the table. So the first thing they want us to do is use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank, indicate units of measurements. So what's happening is my height for my first rectangle is going to be given by this 50.3, and the base of my rectangle goes from 0 to 2. So I can say that my volume is approximately equal to 50.3 times 2 minus 0. And then I can add this next rectangle, which will have a height of 14.4 and a base which goes from 2 to 5. So 14.4 times 5 minus 2. And then my next rectangle, my third rectangle, has a height of 6.5, and it's going to go from 5 to 10. So 6.5 times 10 minus 5. And of course, I'm more than welcome to leave my answer like this, or I can use a calculator and get 176.3 cubic feet. And of course, it's important for me to put cubic feet because they're asking me for the units of measure here. So simple Riemann sum. For part B, it says, does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. And keep in mind, we're looking at rectangles that are getting progressively smaller. But the other thing they told us is that this is a decreasing function. And because this is a decreasing function, that means that all of this extra area that we've included here is just that, it's extra. So we can say that our estimate is an overestimate, and our reasoning is because our function a of h is a decreasing function. So that's what we're looking for here. There's our justification. On part C, it says the area in square feet of the horizontal cross-section at height h is modeled by the function f, given by f of h equals this. And it says, based on the model, find the volume of the tank and indicate units of measure. So keep in mind, from our table, we know that we're going from 0 feet to 10 feet. So our volume is going to be the definite integral from 0 to 10 of our function f of h with respect to h. So we're going to go to our calculator real quick. We're going to integrate 50.3 divided by our denominator of e to the 0.2 times h plus h, and I'm going to integrate that with respect to h from 0 to 10. And so when we do that, we get 101.325. And keep in mind, they want us to indicate units of measure. We're integrating area, and we're multiplying it times the height, so this is definitely a volume. So this is going to be our, what were our units again? Cubic feet. So feet cubed. All right. So that's part C. Going on to part D, it says water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet, and they want us to indicate units of measure. So what we're looking for here is we're looking for the change in area with respect to time. And because of the chain rule, that's going to be the change in area with respect to height times the change in height with respect to time. Now I know this change in height is this 0.26 foot per minute. And from the previous problem, we know that our area is given by this formula. So what I want to do is I really want to take the derivative of that formula. So I'm going to need to take the derivative of this formula, 50.3 divided by e to the 0.2h plus h. And I want to take that derivative at h equals 5, and I want to multiply that times 0.26. So taking our handy dandy calculator, we're going to take the derivative of my numerator, 50.3, divided by, this is going to be e to the 0.2 times h, close parentheses, plus h, close parentheses. And I want to take this with respect to x. I'm going to close parentheses, at x equals 5. And then whatever I get from that calculation, I'm going to want to multiply by 0.26. And so I end up getting negative 0.338884. So negative 0.339. And again, they're asking us for our units of measure. Keep in mind that this is a change in area with respect to time. So this is going to be square feet per minute. So that's question 1.